Good day, good day, good day. Welcome back yet to another session of our daily random questions, right? So today I'm going to be showing you how to derive using the rules, right? Derivation using the rules. So I'm just going to show you a quick rule here that you're going to apply throughout. So on a quick rule that I'm going to show you, this is what you're going to apply, right? So whenever you are having a function, if you want to derive your function, all you have to do, since we have functions that are having a variable and an exponent here, maybe let's say a like that, and here maybe let me put a coefficient being n like that. So what you have to do is that you are going to derive every term. Maybe let's say I'm having two terms here. This is x to the power b and m here. So these are two terms. So what you have to do is you have to multiply this by the coefficient of the variable, right? So we are taking the exponent and multiplying with the coefficient of the variable. So this is kind of like we are going to have n multiplied by a, and then this would be x, and then here we kind of have to subtract 1. So it will be a minus 1. And we are going to the second one, and then we are going to apply the same thing again. We are going to multiply the exponent with the variable. The exponent with the coefficient, So this is the exponent multiplied by the coefficient. So this will be m multiplied by b, and then we are going to have our variable, and then on the exponent we are going to subtract 1. So this is the rule that we're going to apply to derive using the rules. So let's just take it right away. So right now we are having 4 of the equations that we have to derive, right? 4 of the functions that we have to derive. So we are going to take it a step at a time. So let's start with the first one, right? This is simple because it is put in a straight line correctly like that. So let's just apply the rule that I just showed you. So it means that to derive this will become our f prime x being the same as we said this exponent will multiply the coefficient of x, right? So this will be 3 multiplied by 4, and we're going to get 12. And then we said on the exponent we're going to subtract 1. So we're going to subtract 1 there. So this will be x to the power of 2. And then we'll go to the second term. So on the second term, again, we are applying the same thing. So this is the exponent being 4. So 4 multiplied by negative 6. And we're going to get negative 24. And then on the exponent, we're going to subtract 1. So this will be x to the power of 3. And now we move to the last term. So this is 1 here. If there's nothing, so it means that it is 1 there. So 1 multiplied by these 3 of the coefficient, it will still give me 3. And then if we subtract 1 here, it will be 0, right? So anything to the power of 0, so this will be the same as x to the power of 0. So anything to the power of 0 is equals to 1. So this will be the same as 3 multiplied by 1, and we are going to get 3 like that. So the first one, we can just say this is our derivation, right? So we can move to the next one. So the next one is saying y being equals to negative 3 root of x all over 2. And then we're going to have plus 1 over 3x squared. So what we do here is that we have to first multiply out the brackets, or we have to put our equation in a straight line kind of way, right? So let's start. So to put this, let's first do like this. So this is y being the same as, so this situation is the same as negative 3 over 2 being multiplied by the root of x. Do we all agree with that? Yes. So this will be plus, and then now this is squaring this bracket. So every term inside you have to be squared, right? So 1 squared will be just 1, and 3x squared, it will just give us 9x squared, right? So let's continue. So this would be negative 3 over 2. And this, if we use the exponents, if you're having a square root of a number, this is just the same as x to the power half, like that. So this is x to the power half, like that. So plus, and if we're having anything that is having a reciprocal like that, it means that we can take this actually on top. So this will be the same as 1 over 9, and then this will give us x to the power negative 2, like this. So it means that now our equation is on a straight line. So what you can do now, we can apply our rule, right? So it means that our f prime x will be now the same as, so this half will multiply this coefficient, which is negative 3 over 2. So half multiplied by negative 3 over 2, we're going to get negative 3 over 4. And then x, and then this half, we're kind of going to subtract 1, and we're going to get negative half. And then negative 2 multiplied by this, that is positive 1 over 9. So we're going to get negative 2 over 9. And then x to the power negative 2, we subtract 1 again. So negative 2 and negative 1, it will just give us negative 3, like that. So if you're on this stage, you are done, but sometimes you just have to put your exponents in the positive exponents, right? We have to put this in the positive exponents, right? So this is the same as, right, negative 3 over 4, and this is having a negative exponent, so it will be here below, right? So it will be x to the power half, but you can also represent that as square root of x, like that. And on this term, it will be negative 2 over 9, and we are trying to put this into the exponent. So this is the same as 1 over x cubed, like that, right? So we're just going to put it here as x cubed. So here we have derived our second situation, right? Can you see that? Just take a look at that, or you can screenshot so that we can move on to the next one, number 3, right? This is very, very simple, I promise you. If you just look at this and also try to apply this, I promise you that you can be able to solve this. So whenever you're having a question, just try to do it looking at these examples. The more you do, the better you become. So we learn maths by doing maths, right? So here it is 2x to the power 5 minus 3x to the power 4 plus 8x. So we have to derive this, and also we are lucky here because it is in a straight line form, right? So this would be the same as, to derive this would be the same as our exponent multiplied by our coefficient. So 5 multiplied by 2, we are going to get 10. And then here we subtract 1, like I said. So 5 minus 1, it will just give us 4. Moving to the next term, so 4 multiplied by negative 3, we are just going to get negative 12. And then here again, I said we subtract 1. So this will be x to the power 4 minus 1, which will just give us 3. And on to the last term, again, this is 1. 1 multiplied by 8, it just gives us 8. And if you say 1 minus 1, it is 0. So anything to the power of 0, it is 1. So 8 multiplied by 1, it is 8. So we have derived this. So it is simple in this way if it is in a straight line form. So our goal is to first put our equations in a straight line form. So let's move to our last one. Now this marker is not working properly, so let me just use this one. So our number 4, we are having y being equals to 2x plus 1 over the root of 4x. So again, our main objective is to first put this in a straight line form, right? So this would be the same as y being the same as 2x, and this situation we kind of like try to put this like this. So firstly, let's just factorize like this, or let's just deal with this like this. So what is the square root of 4? It is 2 and root of x. And we are going to have a situation like y being equals to 2x plus, and this is half, and then half multiplied by, so this is kind of like below here, so this is the same as 1 over root of x, which is the same as 1 over x to the power half, which is also the same as x to the power negative half, like that. So this we can just put our x to the power negative half where it is supposed to be here. So this is x to the power negative half. So you saw how we moved from this to move here, and also lastly to move there, right? So now it is in a straight line form, so now we can derive. So our derivation now will be the same as, so here there is 1 multiplied by 2, that's a 2, and 1 minus 1 is 0, so this is x to the power 0 to give us 1, and 2 multiplied by 1, it is 1. And now we are going to have negative half multiplied by half, so that will be negative 1 over 4 and x, so we said we will say minus 1. So minus 1 over 2 minus 1, it will become negative 3 over 2. So this is x to the power negative 3 over 2. As I said, when you're on this stage, you are done, but you kind of want to put this in a positive exponent. So to put that in a positive exponent, we are going to say our f prime x being the same as 2, and this is negative 1 over 4, right? And taking a look at this, this is the same as, let me just write it here. So that is saying x to the power negative 3 over 2. So x to the power negative 3 over 2, it is the same as saying 1 over x to the power 3 over 2, right? But this is also the same as saying 1 over the square root of x cubed. If you are struggling with this, please try to check your laws of exponents. If you understand the laws of exponents, it will be very, very easy for you. So we are just going to transport that here. So this will be just over the root of x cubed. So if you enjoy content like this, please subscribe, follow, share, and like. And if you are still having a question, please just email us a question and we'll get straight back to you. See you on the next one on day 14. Enjoy the rest of the day.